So let's maybe continue our today's stream. So oops, sorry, but yeah, no, unfortunately, I don't have premium on this account. Yep, that's good. Yeah, so let's continue. And the first things first. Yeah, so file entry, get size, get metadata, get inode. Yeah, and that's gonna well make it much easier for us because well the because we will be getting the file without getting the actual bytes, right? Which is cool. So we can basically work with the file. I mean, like virtually, right? With the file, with the file descriptor, with its metadata, um, without the um, without the actual having to actually store the or access the file bytes. Yeah, and furthermore, we will be able to fetch the bytes at will. So basically, we're not gonna have to wait, I'll skip this music as well. We will not have to skip the, I mean, like read the whole file as or serve it or whatever. You know, we're just gonna be getting a request from the VFS switch, and yeah, it's gonna be just, yeah, and then we'll just gotta follow it, right? We just gotta follow it, the VFS request, and tell, well, here are these chunks, here are these bytes, the rest we don't care, and the rest is up to the operating system. The operating system's gonna do the all the stuff. So yeah. So it really seems like we can get like a pretty cool things here. Yeah. So get chunks, set chunks, and set chunks for the no, soon. Get chunk. Get chunks. Oops. Let's do the same with this function. Get chunks. I mean, yeah, get chunk slice. But can we actually do the offset length? Yeah. Set chunks back low. Can we? Yeah. So here's yeah, the file chunk. Actually, yeah. make files. Oh wait, for now we're ready with the file entry, though we weren't ready with the directory. And this name, though with the size, right? Wait, let's ask this thing. Price or oops, yeah, that's the advertisement again. Holy shit, I hate it. How are you guys without the YouTube Premium living with this shit, huh? Let's see. I think we have to use the recursion here. Only files need a meaningful size. Should not fake it with. In a professional VFS or reliable file system, the correct answer is only files need a meaningful size. Directories do not have a size. In the semantic case, you should not compute their size recursively. You should not fake it with zeros unless you clearly define it. You should not require all entries to provide size. Yeah. Should the directory size be over? Absolutely not. Counting the directory size recursively is expensive of n, right? That's true. Can explode, costing huge trees. Yes, that's true as well. Can be cached sadly without complex invalidation. Well, kind of. Does not match how real file systems work. Real FS never say directory size is total size of the children. So we can just makes it easier. So FS entry, symlink entry, FS entry, metadata inode, let's get the inode, get size, just we don't care about that. And here in the file entry, base.inode, get size, we don't care about it as well, though we can, I mean, there's a redundancy here. The size and the chunks. And amount of chunks in, yeah, that does not imply the full size, though. The amount of chunks implies the size, right? So we can be like I mean, I think we could leave the redundancy here, right? We could leave it here, the redundancy, right? Right. So the get size we don't even need. Get inode is with base inode. Well, it's good. Yeah. Symlink entry. Crystal ball. simulants and directory entry. Uh-huh. Yeah, let's try and rework it. Hopefully. I'm just U64 FS entry. Yep. Target string for similar entry, get names card check, yeah. Yeah, because it's the main rest. Directory entry, yeah. We're using a unsigned 64-bit, which is I guess it's just more than enough. Yeah, did you forget to close the delimiter? Yeah, but again, I shouldn't have done that actually. Yeah, now you're swapping it one more time, and yeah, here we can go. So yeah. Oh yeah, it's just did a check. Yeah, so we still get the all the indexes and all the fault chunks. So at least we got something here. Here this thing seems in order. Yep, this seems in order. So yeah. File entry, directory entry. Yep, initialize at child get child new child. Oh, so that we're gonna be doing is the inode, right? Yeah. So again, the question remains: how do we generate the inodes? How do we generate the inodes? Hmm. How do we generate the inodes? That's the question. You add the child, remove child. So yeah, your Yeah. So you get basically redundant stuff here. Basically got redundant stuff here. That's I really wanted to get rid of it, but yeah, this shit really seems to be redundant. So wait, for now, we're just gonna be get child, remove child. Yeah, for now we're just gonna be doing with this set chunks, list children. Same with list children self offset length. Usize. Yeah, usize. That's it. That's good. Yeah. So, oh my gosh, I see that the music still was the advertisement. I really hate it. So yeah, whatever. List children. It should work as well. Yeah, it seems to work. Okay, so sibling entry. Target. You get target, set targets. Yeah, that's basically yeah, that's basically what we need here. Yeah, well, let's first make it commit. Initial commit. Wait, but no file description re what the types for press and repository file link and a copy one in your base share. Sorry. Yeah. So what are we gonna do now? Now we're gonna, well, file system we got. Um, wow. In press. File and I'm afraid now I'm gonna see a lot of shit hit the fan. I'm afraid, but yeah. Mod entry, file entry. Oh yeah, that's gonna be public. Chunks and range. Oh, chunks and offset. So no overloads actually are allowed. Fuck. Because it would have been so nice to have like overloads here. entry base. Get an achievement and get fast tracked. The queue is not implemented for FS entry. Oh yeah, yeah, sure. We should have actually. Partial EQ. Clone is not implemented for FS entry. Yeah, so okay, we can just clone it around. Yeah, we have to implement the cloning. So that's unclonable now? Good. I mean, not good, but private field, private field, private field. Yeah, these are private, so actually as they should be, right? Now we're getting somewhere, but whatever. File, it's file entry now, okay. So what do we have now? Basically the same, right? So it's not clonable, nothing. Yeah, but we should be really careful cloning it. Because here's the thing, right? Here's the thing. We cannot confirm. Cloning it would actually mean that would create a hidden dependency. That would create a hidden linking. That would really create a hidden link because here's the thing again. Since it's cloned, we can. Sorry. Yeah, since it's cloned, also the values which represent what which also the values which represent all the chunks and where to find them are going to be cloned as well. So there will be two files pointing at the same chunks, which is more of a deep clone, but that's not good. We can have two files, two different files, the file descriptors, pointing to the same chunks. Well, what we actually also have to do is, for the file, we have to add locks also, and synchronize them as well. For simultaneous writes, for example, that the write operation should be halted until and then it should be queued. Yeah, it should be queued until the previous lock releases. And though since it's not a database, there will be no mutual locks and no deadlocks, because I mean, like, I'm either writing the file or not, yeah, maybe we'll even That's actually a good idea. Why to ask? And that's question I actually do not know. File log semantics are mandatory. Okay. Share most specific another other process may read, write, or delete the file. Process A opens will not write sharing or delete sharing. Process B tries to write and then Windows blocks. Okay. This product is a familiar. This action cannot be completed because it's a file in use. Advisory logs, not mandatory ones. By default, multiple processes can open, rewrite, and delete the same file. Application may coordinate. Music F log, F control, log F, but the OS does not enforce its logs unless or participating applications voluntarily check them. So Linux just says, well, I don't care. Do whatever you want. Logging is something you have to do, not me. It's just a mounting. Yeah, that's only if only that's voluntarily. Okay, but in our case, it's not gonna happen. I think we'll have to. I mean, it will be very nice to implement our own locking features. I mean, because I have a feeling that I probably should. And I mean that there's gonna be a brief one because I just until the write is complete. I mean, like there will be like a bunch of writes. Let's say I'm gonna like writing a bunch of chunks of data. And yeah, and until the chunks of data are written, and by written I mean synchronized and acknowledged from all the nodes, will be basically there. So yeah, the file system we got. Let's create a node. Bloody hell! Is this ads coming up again? Again, I'm paying for. I have the YouTube Pro though from another account. Right. Okay, so what we're gonna be doing now? Yeah, node. What does the node have? A node have a certain entry. A node has a certain entry, which is basically a directory. A node has basically a directory. So that's what we're gonna be starting with. Node address. Strict struct. Or node. Yeah. node. Yeah. Um. Hmm. I'm just trying to think about what happens next. Struct node. What does a node have? Maybe a certain ID and a certain capacity. Um, a certain storage used. Well, maybe I guess maybe. Oh, I mean, well, we can get rid of it like anytime. sorry, sorry. And the directory entry. Root entry. FS entry. Oh, it's not the box FS entry. It's just the dynamic. It's just root directory entry. Yeah, directory entry. Though I think that the struct's gonna be maybe use it as a box uh to allocate it on a heap. Does it make any sense to use it to well allocate it on a heap? Does it? Does it not? Cool. Huh. All right. Nope, we cannot derive it. We can use create file system directory entry. Yeah. So box. Oops. Yeah. It's just a box. Um. Give me a second. That's box. Which well, a box is from what I know. I mean, I'm coming from Java and C++ world. The box is basically a shard pointer or smart pointer basically. So for me, it's easier to think of it as a shard pointer, which has a reference counter, I guess. Um, in C++ definitely does it. It has a reference counter, so we don't have to bother deallocating it, which I mean that which saves a hell of a time. I gotta admit. And I believe it also has some heap fragmentation stuff, though not sure. Box versus box dynamic. Um. Um. Wait. In and important features. So a heap allocated value of concrete type directly entry is a concrete struct from stdfs. Bullshit. It is not. It is not. But we can live with it. It is not. So that's not the exact size and compile time. Nope. It does not because um heap allocated, no dynamic dispatch involved. You can call methods direct on it because it's type. This is a trade object. Exact size yeah, it's basically dynamic. Type node and compile time, yes, no. Dynamic dispatched, no, yes. Memory says no and compile time, yes, no. Um, though. Um, yeah, though. You have, there is a concrete struct, so, Rust does know it has a compile time. Is a pointer. So yeah, it knows the structure and the compile time. It knows sorry, this entry, it knows the compile time. And this is just a pointer, which is a 64, I mean, this is just a hash map, with the hash map actually being a pointer itself to dynamically allocated stuff. Though, this thing is basically reduced to a pointer. And we just know that that I believe like 8 bytes is a 64-bit pointer. How large it is? I can remember for sure. I'm sorry, but that should work. That should be good. We're good with it. Good. Yeah. So yeah. Let's function of a fan init. fs.new, some metadata. All right. Name. Huh. I mean, there's just a placeholder, right? But new thing is new. Oops. Yeah, this looks better. That's better. Okay. No, it creates a node with another node ID. I know. Yeah. So this thing basically creates us a directly. This thing basically creates us a direct well, structure we need, right? Um fucking it, sorry. Yeah, let's create leases with everything we need. Yeah, we'll leave it for now. But here comes the next question. ABFN. So here's. Oh wait, I really got to think about it. Does it make sense to serialize all the node? I mean, again, we're not talking about any files here. We're just talking about descriptors here. We really gotta, well, figure out to store the file descriptors here, or not, or whatever. We really gotta know what to store or what not to store, or whatever. So this is the node is the point, but here's the thing. See, I'm just a bit afraid of storing the whole thing. I mean, like we gotta, yeah, that we gotta. I mean, like on every iteration, basically, or on every file change, we gotta just yeah. Again, storing is for me just like writing the bytes to disk and then putting them from disk again or on the next boot up, right? And then like syncing them. Yeah. So yeah, serialize for now. We're just gonna be leaving out it. The yeah, screw it. Symlink entry. Yeah, so this code is yeah, it's from file. Oh my god, I love this code. But unfortunately, I believe we were actually the same image we're looking at here. But I'm afraid we're gonna have to leave it out for now, and we're gonna have to rewrite this thing again. You see the file chunk here. Although the file chunk it's gonna be somewhere else. Yeah, again this the node itself actually we will have to do this is the root directory, and we'll have to create a hash map showing us real files. It's a hash map which is gonna show us real files. And I mean like real files like locally where we can find them locally. Obviously those won't be real, like real, but like these gonna be the parts of our files, right? The chunks 4 kilobyte each, I believe. Quick pardon, yeah. We're at 4 kilobytes chunk now, so that's what we're gonna be. That's what we're gonna go with. Yeah. So for now, let's unveil the Mighty Eye. Unfortunately, I'm not very familiar with the ViewsFS. And write a small, well, not small. Let's start writing a ViewsFS, right? Libviews. Yep, so let's install Libviews dev. Oops, alright. We're good to go. We are good to go here. Yeah, dependencies Tokyo. Is the main fuse rest library. It's the main fuse library. Tokyo will be used for async networking, log and log help for logging. Yeah, Tokyo, we don't care about it actually, no. Right. use 3 lamps. Zero 0.3.1. Huh? Yep, let's just go with it and add the latest version possible. Use 0.31. Oh, or I'm sorry, yeah. Right, the main of these are C's. It's gonna be res. Not alt, because I mean, we're gonna get to it sooner or later, but let's just do like a simple test here, right? Working layer, we don't care about it. Pikachu. My request for refuse was not found. Oh, what the fuck? Sorry, but yeah. To environment variable, you can run the following. Necessary tools. Yeah, that's the page. So again, Lips, lab refuse is nowhere to be found. Shit. Yes, I mean that's a must in this case. That's a must in this case. It has to be used, but I mean, yeah, I know they're we're really heavily dependent on no, so there's something else with use that for that. Oh, yeah, there's something. Use arrow. Okay. Yeah, we're not gonna be using Tokyo right now. So yeah, let's. Okay, we're not gonna be using. Not now. Not now, at least. because again, Tokyo generally adds complexity. Um, yeah, Tokyo generally adds complexity, which I really don't know, don't want to bother with now. So, oops, sorry. Yeah, um, so it tells me views error or something else. First of all, the top isn't there. Um, all right, likely separate thread if you want to handle async tasks. We do not care about it now. It's everything is just single threaded and RT non slash TMP slash whatever. Tokyo runtime. We do not need this now. We just want to take a look at the capabilities and my tests. Yeah. So yeah, I messed up here. I assumed that there should be a Tokyo integration, which it doesn't have. Should not be. What the fuck, right? And again, I'm just curious what this as we know, AI it just can't code properly. It just can't. Look at Kia. Yeah. It's just there's no way we're gonna get something useful out of it, but we'll give it a try. As you see, I mean, you see how much more errors there are. Like, again, I'm just I'm really just freaking curious. Again, we have proper descriptions here everywhere, but yeah, I'm just curious whether there's no way that's gonna work. There's no way that's gonna work fine. Again, I mean, like, AI messing up. It's complicated. I haven't seen, I believe, not a single time that it hasn't messed up. Though now it seems that slash TMP slash mount. I'm gonna open up the terminal. Let's carve around it. Yeah. No such file directory. Slash mount. Oh, slash mnt. Our user has no writing access to let's pass. Pass. Oh, hi! We got on something here. Unable to open, right? And unable to open as well. A function not implemented, right? Yeah. Though, as you can see, Can we delete the file actually? Delete. Move to trash. Delete permanently. And it doesn't happen, nothing happens as well. So we got something at least here. Hooray. Um, yeah, again, later we're just gonna move the FuseFS into separate daemon. Yeah, it's gonna be moved separately. Just gonna be moved separately. FuseFS and yeah, it tries to push the test fast and it doesn't work. Yeah, see, it can't even open the fast. It's not even there. Test fast. It's not even there, right? Yeah, sure. That's comment and push. Yeah. Now that holds fine. Now it works. It's the fast. Yeah. Oh wait. Delete it. Delete permanently. Oh, so the file exists. My file here just messed up a bit. So, yeah. We have here the regular file, right? File attribute. So basically, we can request the link. What is an end link actually? Flags, log 0, size 0. Yeah. What block size is here assumed actually? Mission mode. SU16 permission. Git UID. Make directory. Get net repeats for inode. Rendering. Though this shit doesn't work completely, as I mentioned. Transport endpoint is not connected. That's the pass. Um, yeah, shit. Slash test of S slash slash mount. Oh, so we gotta really unmount it. Oops. Yeah, so we had to really unmount it. Slash mount, slash end mount. Makes sense again, sort of. Oops. Okay. Huh. Test fast. Oh, I see it even here in my storage. I mean in my Dolphin. It's called, isn't it? Like in the file explorer, whatever it's called in Gnome. The location could not be displayed. What the fuck? Open. Victory. Codes. We gotta look for libc now. Even the libc we have to add separately. What the fuck? Right. Alright, okay. We'll implement it. Oh. Yeah, guys, I'm gonna end the stream for now, and I'm gonna take a look at this myself a bit later. So